Good morning, one and all. Welcome to another session on data mining. I'm Dr. Diana here. We have been We started with Unit 2. Unit 2, I said, we are dealing with frequent item set generation, and we are going to look into two different algorithms to help us mine frequent patterns from large databases. Now, we looked into an example of a frequent pattern. A pattern is something that has a predecessor and a consequent. A predecessor can be an event and the consequent is another event. We understand the probability of occurrence of these two events using two mathematical measures called as support and confidence. We looked into an example with item sets generated with 2 items, then with 3 items, and we saw anything that has a support value of more than the minimum support threshold mentioned by us, it can be considered as a frequent item set. In this example, if I consider 2 to be the minimum support value, then all those which are in red color cannot form a frequent pattern, which means the support value is less than 2. And if I consider that the confidence value should be more than 50%, then all the purple ones cannot become frequent because their confidence value is less than 50%. So based on these attributes, we generate patterns, and the left out patterns which are black in color are both frequent and they have a confidence of more than 50%, which helps them, or these I can see they have a high support value and they have a high confidence value, which means they are prone to repeat in the future. So this is an example that we have seen already. Now we will move into an algorithm for doing this, or what was the difficulty in doing this manually. Then we will go into the algorithm. Okay. So what is the difficulty we have here? Now when I have 5 item sets that are there, it is computationally very expensive to create all possible combinations. Now suppose Walmart has got 10 power 4 kind of products. 10 power 4 is not a big number, it's only 10,000 products. Do you think DMart will have less than 10,000 products? A pen is a product, a gum is a product. Even the same product, such as, say for example, tomato sauce, there are 4 varieties there. So when you count products like that, 10 power 4 is a very less number. But when I try to get all potential combinations at every level to determine the next set of items, then it becomes computationally very intensive. So I'm going to use certain set principles which can help me generate frequent patterns easily. Instead of identifying every possible combinations and then trying to find their support, which are the best or which are most probable frequent item sets. For doing that, we will use an algorithm and some principles. Now the algorithm that we are going to use, the algorithms that are available are Apriori, FP growth and ECLAT. In your curriculum, it deals only with Apriori algorithm and FP growth algorithm, or the frequent pattern growth algorithm. So we will not look into ECLAT algorithm. in our sessions. We are going to start with a priori algorithm. Now, a priori means to know something in prior. We are going to use a property called as downward closure property, which is the base of the a priori algorithm. What does downward closure property mean? It means any subset of a frequent item set must be frequent. Say for example, now when I look into this example, I say pencil glue is not a frequent item set. Pencil ink is not a frequent item set. So if I have a combination in L3 saying pencil glue ink, it will not be frequent because its subsets pencil glue, pencil ink are not frequent. That is the downward closure property. It means if bread diaper nuts is frequent, then bread and diaper must also be frequent. Every transaction having beer diaper nuts also contains beer and diaper. That is the basis of the downward closure property. This is used in two approaches, all a priori and frequent growth approach. Both of them use the same property. We will see how this property is practically used. Now imagine these are the item sets we have. Now if I have D number of possible items, I have got A, B, C, D, E. So I have 5 possible items. For 5 possible items, I have so much of combinations possible to reach the 2 item sets. 2 item sets means A, B, C, D and E separately are called 1 item sets because they have only one item given in their list. The second level gives 2 items, combination of 2 items, that is called as a 2 item set. When I go into combination of 3 items, it is called as 3 item sets. Then I have 4 item set, then I have 5 item set. Now this is all the possible combinations for any given set of items. Now, if in the a priori principle it says all non-empty subsets of a frequent item set must be frequent, which means I use the same downward closure property and say if I want any of a item set to be frequent, then all of its non-empty subsets should be frequent. Only then I can consider that item set as candidate for frequent items. If an item set is not frequent, say for example if a combination AB is not frequent, no other combination having AB will be frequent. I can say ABC will not be frequent, ABD will not be frequent, ABE will not be frequent, ABCDE will not be frequent. So if the combination AB is not frequent, then none of its supersets or none of the other combinations that contain AB can be frequent. Okay, so that approach I am going to use when I am trying to generate frequent item sets or frequent patterns. So this a priori has a pruning principle. So every time I try to generate some item sets, I am going to check if all its previous subsets are frequent. If they are frequent, only then I have a chance that the superset can be frequent. Otherwise, I will not generate my superset and I will not calculate the support value of that particular superset. Such a principle is called as the a priori pruning principle. Now we will look into the algorithm. with an example. Now, this is the example that I said. Now, AB is found to be infrequent, or AB does not satisfy the minimum support threshold value. Then none of the supersets that contain AB can be frequent. So all of them will become infrequent supersets. ABC will become infrequent, ABD, ABE, and all the 4 item sets that contain the combination AB will become infrequent. The 5 item set with the combination AB will become infrequent. So based on this principle, I am going to cut off this tree and I am not going to generate or calculate their support values and confidence values. Is that clear? So when that is the case, this reduction of certain parts of the combination without calculating the support value, I can just like that close my eyes and blindly say they will be infrequent. That is the a priori principle. Or I am going to prune or cut this part of the tree from the support value calculation. So that is called the a priori pruning principle. Now the algorithm has a basic idea. So what it does is it has 2 steps. The first step is called join step and the second step is called prune step. During join step, I generate all possible combinations of size k plus 1. Say for example, I now have the first level of item sets. So I can generate level 2 item sets by combining 2 frequent item sets of size k. So any 2 frequent item set of size 1 I will combine and to form a 2 item set. That is called the combination or join step. After I generate all possible combinations, then I will perform the prune step by looking backwards. I will look back and see if all the subsets of that combination is available in the previous frequent item set. If it is available, then I will consider that as a frequent item set, or I will remove that. Now when I'll give you an example so that it will be easier for you to understand. Now this is an example. I have a list of items. The item IDs are given here as I1, I2, I3, I4 and I5. So there are 5 items and I have got some transaction IDs for purchase of these items. So I have got 9 transactions in which different combinations of certain items were purchased. Now looking at this, now I am going to generate some set or combination of item sets. First thing I do is, before the algorithm begins, in the first iteration, each item is considered a candidate. So every item is called as a candidate. So the first level I generate is called as candidate 1 item set. The candidate 1 item set includes all the items listed as I1, I2, I3, I4 and I5. All of them are listed there. And the support value of each of these items is calculated. Support count is the count of number of transactions in which that particular item is presented or bought. Now when I look at I1, I have transaction ID 100, 400, 500, 700, 800 and 900 in which items I1 is purchased. So my support count for I1 is 6. And for items I2, the transaction ID 100, 200, 300, 400, 600, 800 and 900. So there are 7 transactions in which item I2 is present. So the support count of I2 is 7. Likewise, for I3, the number of transactions in which I3 is present is 6. The number of transactions in which I4 is present is 2, and the number of transactions in which I5 is present is also 2. So the first step in the a priori algorithm is arranging these item sets. So I am going to assume that the minimum support value is 2. Anything to be considered as a frequent item set, I should have a minimum support value of support count of 2. Now these are all the possible combination of one item sets. So this is called as the candidate one item set or C1. In C1, I check the support count of all items and check which of these items have satisfied the minimum support count of 2. Fortunately, all of them have minimum support. They have either equal or more than the minimum support value. So all of these can be considered as frequent one item set. So frequent one item set is going to be called as, so I am going to scan this entire database and then call L1. All of them have satisfied minimum support. So all of them are going to become frequent item sets. L1 denotes frequent one item set or item set that satisfies the minimum support threshold. Now from L1, I am going to generate C2 or all possible combinations of two item sets. So I am going to combine all item sets in L1 to form two pairs of items, and then I am going to scan the support value. So these are the possible two item sets. I have I1, I2, I1, I3, I1, I4, I1, I5. Then I2 with all the others. I2, I1 and I1, I2 are the same. So I am not going to repeat that transaction here. So you can see I2 starts with the combination of I2, I3, I2, I4, I2, I5. And I3 starts with the combination of I4. So I3, I4, I3, I5. And I4 has got a combination with I5. These are all the possible combinations in two item sets. So it is called as candidate two item set, which are generated from frequent one item set. C2 is the candidate two item set and L1 is the frequent one item set. Now from this I have to calculate the support value. Now I am going in, before I calculate the support value, I am going to scan the database for count of each of the candidate. So the support value for each of them, let me look back. From this set of transactions, tell me what is the combination I1, I2 is having. The support count of I1, I2 is the number of transactions in which I1 and I2 are present. So I have transaction ID 100, transaction ID 400, transaction ID 800 and transaction ID 900. So I've got 4 transaction IDs in which I1 and I2 are present together. Now calculate for the combination I1, I3. What are the, how many number of transactions are having both I1 and I3 together? I have transaction ID 500, transaction ID 700, transaction ID 800 and transaction ID 900. So totally there are 4 transactions in which the combination I1, I3 occurs. The same way I am going to calculate for all possible combinations of C2, and this gives me the value I1, I2 4 times, I1, I3 4. So I have got the list of all the support count for all possible combination. Now I am going to perform the prune step. This is called as the join step. The step in which I find out all possible combinations is called as the join step. C2 generation is the join step. Now I have to find which of them is frequent. Compare the support with the minimum support value. The minimum support value that I assumed was 2. So for C2, how many of the item sets in C2 are satisfying the minimum support value? All of them will become part of frequent 2 item set, or they will become a part of L2. So I have I1, I2 has got 4. So I1, I4 is removed. I3, I4 is removed. I3, I5 is removed. I4, I5 is removed. So the rest of the combinations form frequent 2 item sets. 2 item set is an item set where there are 2 items. Clear? So this L2 becomes frequent 2 item set. Now in the next step, I am going to perform the join step and find out all possible combinations of L2 to form the level C3. C3 is the candidate 3 item sets, which includes all possible combinations of L2. When I am generating C3, I am going to have, now imagine this is my frequent item set. I have the predecessor to be common. I should have the predecessor to be common. So there are 3 transactions in which the predecessor I1 is common. So to form I3, to form C3, I can have I1, I2, I3. I can have I1, I3, I5. Clear? These are the 2 possible combinations, and I1, I2, I5. So there are 3 possible combinations for the first 3 item sets of L2. Is that understandable? So for the first 3 item sets of L2, if you consider I1 is the predecessor, so I can form 3 possible combinations out of having I1 as the predecessor. So it can be I1, I2, I3, I3, I5, I2, I5 along with I1. But the same way I have to generate for I2 also. There is a predecessor I2, the next 3 combinations of L2. So when I talk about this, I can go in combination of I2, I3, I4, I2, I4, I5, I2, I3 and I5. These are the possible combinations. Now when I am generating that, I look back and say all its subsets should be, what does the a priori principle state? All of the subsets, all of the non-empty subsets should also be frequent. Now consider the combination I1, I2, I3. What are the subsets? I1, I2, I2, I3, I1, I3. These are the possible combinations. Are all of these combinations available in L2? Yes, they are available. In that case, I can take it as a frequent or a candidate in C3. Now consider the combination I1, now consider the combination I2, I3, I4. What are the subsets of this combination? I2, I3, I3, I4, I2, I4. All of them, are they present in L2? I2, I3 is not, I3, I4 is not present in that L2. I3, I4 is not a frequent pattern. So, I2, I3, I4 combination cannot enter inside C3. Is that understandable? So, in that way, if I rule out and find out my item sets, I've got only two possible combinations for candidate 3 item set. They are I1, I2, I3, I2, I1, I2, I5. Now the prune step. We will have to perform the prune step by finding the support value. Now I am going to scan the database for finding the count of each of these candidates, and it gives me the support value for each of them. So for the first combination I have the support count as 2, and for the second combination the support count of 2. Both of them satisfy the minimum support value. So both of them are frequent 3 item sets. So L3 includes both of them. So this is the entire algorithm. I start with C1. I check with the count its support. Then I compare with the minimum support and form the frequent one item set L1. Then I have the join step which generates all possible combinations C2. Because all possible one item sets are frequent one item sets, I am not having any prune here. All of those that are in C2 are checked with support value. Now their support values, depending on the support value, I calculated the support count for all C2, all possible combinations, and I saw that some of them have values lesser than my required minimum support threshold. Those candidates I have removed, and I formed those candidates I pruned out and formed the L2 or frequent 2 item sets. From frequent 2 item set, I generated possible combinations of C3. I scanned the support count for all of C3 and identified L3. Is that understandable? I hope this is understandable. So this is Apriori's algorithm for candidate generation and frequent item set generation. In your examination, you will be given a set of transactions, a set of transaction IDs and a set of items which are purchased in different transactions, and you will be asked to generate frequent 3 item sets. So this is how we generate frequent 3 item sets. First is identify the support count of all one item set, all possible one item set. Then scan the database and identify if all of them are frequent. Then you perform the prune step by eliminating those that are not frequent. Then form L1. After L1, you form C2 or candidate 2 item set from all possible combinations of L1. For all the elements in C2, find out the support count from the given set of transactions. Then whatever is having less than the minimum support value, they can be pruned, and then you generate L2, which is frequent 2 item set. Then from L2, we generate the candidate 3 item sets C3, which gives all possible combinations of L2. And it is there we use the principle of a priori that states if an item set is frequent, then all of its non-empty subsets have to be frequent. So when I am generating C3, I should be carefully generating and checking back with L2 if all these combinations are present in L2 or not. So that will help us understand the L2 better. So with that we have found out C3. After we have C3, we will have to generate support count for all elements in C3, and if they satisfy the minimum support value, then you can form L3. This is how we apply a priori algorithm. Now I am going to show you a pseudocode for the a priori algorithm. Here you can see the first step is CK means candidate item set of size K. LK means frequent item set of size K. The first thing we do is form L1 or frequent item sets at L1. Then we go from k equal to 1 till k is not equal to null. We keep repeating the process of join and prune. The first is generate ck plus 1, or generate the second level of candidate item set from the first level of frequent item set, or in the first iteration it will be generation of C2 from L1. Then for each transaction you go inside the database and you find out all the candidates in ck plus 1 that are contained in that transaction. So I am going to find the support count, that is what I say as increment the count of all the candidates. Then form LK plus 1. LK plus 1 is L2 for the first iteration. L2 is the list of candidates in C2 with the minimum support value. The same way for the second iteration, it will be C3 and L2, that way. So you do it like that, and then you return finally the set of all frequent item sets LK. Now this is the working of a priori algorithm. We will look into one more example in the next session. For this session, I stop it here. Thank you one and all. Stay home, stay safe. Hoping to see you all in campus very soon. Thank you.